Hi, my name is Zoran. Today I will show you how you can manipulate contents of lists and arrays and make that code run very fast. By the end of this demonstration, you will see me rewrite one example and make it 50 times faster than it was. And you will even see me break LINQ of substitution principle on a regular basis with the lists, and nobody will care because there will be a huge gain in performance. But let's not rush, one step at a time, you have to be patient. We'll start with some basic code. There will be an array with some random data and an exact copy of those data in the list. Now I'm interested to know performance of some typical operations like just iterating through the array or iterating through the list. Of course, you can pass any of these to a method that receives an enumerable, and then for each through the data, but you already know that there will be a high penalty connected to this way of iterating. So yes, I can invoke this function with both the array and the list, but I do expect penalty. And so we come to a much faster method of iterating. You can create a span out of an array. Span is fast. Span is a structure which is always located on the stack. It cannot escape to the managed heap. It is providing fast access to the array's elements directly, and you will see the measurements will confirm that. You can initialize the span directly from the array, but you can also assign an array to span because there is an implicit cast operator defined for that. You can use spans on the lists. The span is allowed to access the underlying array inside the list. There are certain considerations here. You must never add or remove items to the list while there is a living span connected to it, because add and remove operations on the list may cause that underlying array to be reallocated. And then the span would point to stale data and your code would produce an incorrect result. There will be no runtime exception if you do that, but the result would be just the result of using the old version of the list, and that would probably not be correct. If you wonder what is happening inside the list when you use it, I have published 2 videos on that topic. You can watch them on this channel. But again, if there is a span on the list, you must not add and remove items until you're done with the span. Use that span to process both the array and the list uniformly. You see, the span is used similar to the array. It has the length, you can iterate with the for and access elements of the span just like elements of the array. So the question is, how fast is this? I have prepared benchmark for that. Let's see the results. Well, it turns out that bare array iteration is the fastest. That may come as a surprise if you have heard that spans are the fastest way to iterate. Well, there seems to be a small penalty compared to the bare array. But listen, we are fighting with extreme performance optimizations in .NET here. Converting a list into a span and then iterating the span is producing 40% improvement in speed when just walking through the list. Let's add more requirements then. Let's add pressure. What about changing the content of an array and a list? I have prepared another set of benchmarks. I am modifying the array back and forth. I am using the random access to array's elements to complete this operation. It's a non-trivial transform. Let's see the result. Oh yes, before that, I owe you that story about the LINQ of substitution principle. While using the list as a span, maybe you had the feeling that I am breaking the LINQ of substitution principle with that code. Let me tell you something about that feeling of yours. You may have it because, yes, I am breaking the LINQ of substitution principle. If you substitute one object a span into an array with another object with the same type, a span into a list, and the code suddenly breaks because you were modifying the list while using the span on it, then you have effectively broken the list of substitution principle. Why do we tolerate that? How come that .NET contains the span type, which is breaking one of the fundamental principles of object-oriented design? The answer is very simple. Look at the results. It is the speed that makes us use the span, even though we know it is dangerous. 40% of speed when transforming the array, and 60% of speed when transforming a list using the span to its underlying array. But let's step to the most complicated demo. Now this is the time when I ask you to like this video if you find this explanation useful in your work. You will help me a lot if you just liked this video. Thank you. Now to the example. The request is to modify one part of the list or the array. But all we have is some transform function which may receive a list. To call this function, it seems that we must slice the list, for example using the getRange method on the list. That method will construct an entire new list object and populate it with a part of the original list. Then we modify this part of the list by passing it to the transform function, and then when the function completes? We must pass through that modified segment of the list and put it back into the original list, overwriting part of its content. This is an exceptionally costly process. A more general transform might receive an IEnumerable. We really do transform the data with IEnumerable all the time. The entire LINQ is based on this idea, because you can use the lazy evaluated LINQ operators to slice the list without effectively copying anything from it. Can we use the span? A span would either come from an array or from the list, you know that already. Then you slice it to obtain a new span, a window into a part of the list or the array. Now, here comes the magic. When you use spans, you don't do memory-to-memory copying. There is no copying of data. When you create a span, when you slice it to get a new span, a span is just a window into an array in memory, nothing more. So when you slice it, you get a new window, but no data move. No data at all. So the time and space complexity of this operation is O of 1. You don't get it much cheaper than that. And the best is yet to come. There would be a function which receives a span, and its implementation will be optimal, much better than LINQ, because you have random access to memory. You can do the best to make that transformation as fast as it can be. Just slice a span originating from the array, for example, pass it to the transformation function. Transformation happens in place, there's nothing to copy, there's no overhead, just do the job and you're done. The same is with the list. Here's the new benchmark. The LINQ transform is very short, one-liner, but exceptionally costly. You will see that in a moment. And the span transformation function is verbose, long, complicated, but it is optimized. So, look at the benchmark results. Enjoy. The span is consistently 30 to 50 times faster on the list, primarily because of the two effects. One, no memory-to-memory copying when you use the span. You're only using the descriptors where the data are which you want to transform. And a second, you have access to all the elements, so you can really perform an optimal transformation. You don't need to store the data aside as the LINQ operator would do, then to combine them, do multiple passes. That is not necessary here. If you liked this demonstration, please like this video, I will appreciate that, thank you. And you can also watch the other videos on my YouTube channel. You can also learn a lot from my Pluralsight and Udemy for Business video courses. Thank you for watching and see you in the next video.